Begin by creating a new ladder project. If you're working with an actual PLC, be sure to select the appropriate model that corresponds to the PLC you are using. You can assign specific names to each device, including inputs, outputs, memories, and data registers that will be used in your ladder program. Doing so can make it easier for others who need to comprehend and work with your program in the future. Now, at this point, we can implement all the rungs we discussed earlier. Over here, you can find all the instructions we talked about previously, such as normally open contacts, normally closed contacts, positive edges, negative edges, and so on. Providing clear statements or titles for each rung, explaining their specific tasks, are a valuable practice for enhancing future understanding of your program. As you progress, you may need to troubleshoot or modify the program, and these well-defined labels will prove invaluable during those times. Compiling a ladder program after writing it is a crucial step in PLC programming. It serves several essential purposes. First, it helps detect errors in your code. This includes spotting syntax mistakes or logical errors that could cause problems in real-world scenarios, which is especially critical in ladder logic. Second, compiling translates your human-readable ladder logic into machine code that the PLC can understand and execute. Without this conversion, your program won't work. Furthermore, if there are any errors or warnings, the compiler provides feedback to help you identify and fix problems, ensuring your program operates as intended. So, remember to compile your ladder program for error-free, efficient, and safe PLC operations. After compiling the program, don't forget to click on the Start/Stop Simulation button before proceeding to the MXOPC configurator. The MXOPC configurator serves a crucial role in connecting your PLC program to factory I/O. Its primary purpose is to establish communication between the PLC and the factory I/O simulation environment, enabling real-time data exchange. By configuring the MXOPC configurator, you bridge the virtual and physical worlds, allowing your PLC program to interact seamlessly with factory I/O for testing, simulation, and validation. Begin by creating a new database in MXOPC configurator. Next, create a new device. Using the pop-up window, you can configure communication settings, including the CPU series of the PLC and PC side communication interface, as shown here. By selecting this command, you can verify the connection status with the built-in simulator of GXWorks 2. However, remember that you should initiate the simulation from GXWorks 2 beforehand, as mentioned earlier. Now you can proceed to add data tags corresponding to all the inputs, outputs, and data registers used in our ladder program. Alright, let's move on to the exciting part. Before starting the simulation, we must establish a connection between GXWorks 2 as the PC side interface and the factory I/O simulation environment. To do this, select OPC Client Data Access from the driver window. Once you've made that selection, proceed to the configuration settings and follow the steps shown here. You can now drag and connect all the inputs and outputs to this virtual PLC, just as demonstrated here. Before starting the simulation, just like in the real world, we must download our compiled ladder program into this virtual PLC within Factory I/O. To do this, use the Write to PLC command in GXWorks 2. Once the program is downloaded to the PLC, press Start Monitoring to begin real-time monitoring of this virtual PLC's operation. Alright, now return to Factory I/O and click the Play button to transition from the Edit mode to the Run mode, and observe your virtual integrated process in action.